Hi everyone and welcome to this video. My name is Mehdi Tarzou. I am a network solution engineer at Alcatel-Lucent Enterprise. In today's video, we are going to focus on the seamless integration of Alcatel-Lucent Enterprise OmniSwitch and OmniAccess Stellar with the identity management solution Cisco ISE from Cisco. In our hyper-connected world, the ability of different networking components to work together harmoniously is paramount. Cisco ISE, known for its robust security and identity management features, plays a pivotal role in securing your network. But how do you ensure that it can collaborate seamlessly with your Alcatel-Lucent Enterprise OmniSwitch and OmniAccess Stellar? Or even, how can you make a smooth transition to it? That's where I come in. In this video, I will show you how Alcatel-Lucent Enterprise products, including Alcatel-Lucent Enterprise OmniSwitch and OmniAccess Stellar, can communicate effectively with Cisco ISE, ensuring not only security, but also performance, scalability, and manageability. By the end of this video, you will be convinced that you can use the most cutting-edge technology products from Alcatel-Lucent Enterprise seamlessly with Cisco ISE. So whether you are a network administrator, IT manager, or planning to make the transition, this video has some things for you. I will first introduce you to the two use cases we will cover today. Then I will explore with you the essential configurations and best practices required to establish a cohesive network environment. Finally, I will close with some key takeaways. Let's get started.
.1x is a network authentication protocol that provides secure access control for wired and wireless networks. With .1x, users must authenticate themselves before gaining access to the network, ensuring that only authorized individuals or devices can connect. For this demonstration, I have a client that I will use to connect to an SSID using .1x authentication. The access point is configured to use UPAM as the authentication server, which will actually proxy the request to a Cisco ISE server. Indeed, the user's credentials are stored in the Cisco ISE database. After responding to the IAP challenge, Cisco ISE will send a radius access accept packet to UPAM, which will be proxied back to the access point, granting the access to the endpoint. In this demonstration, I will first create and configure an SSID in OmniVista using .1x method for authentication, and apply it to the access point. I will then create a user in the Cisco ISE database, and then use them to connect the endpoint. Firstly, I need to create an SSID. To do this, I will navigate to the Wireless LAN tab and then select SSID. Once there, I click on the plus symbol to add a new SSID. Now I can enter the desired name for my SSID and choose the .1x Enterprise Authentication method. For this demonstration, I won't be using a captive portal, so I make sure to leave the option for captive portal usage unchecked. Once I've entered the necessary information, I move forward to create and configure the SSID. On this page, I locate the authentication strategy box. By default, UPAM is selected as the radius server. However, I want to make some advanced configurations, so I click on the Advanced Configuration button. In this Advanced Configuration settings, I choose an external radius server as the authentication source. Specifically, I select Cisco ISE. This means that UPAM will act as a proxy, forwarding the authentication requests to the Cisco ISE server. Now that I've made the selections, it's time to apply the change. I scroll down to the bottom of the page and click on the Apply button. If prompt, I confirm the action by clicking Apply once again, ensuring that the SSID is applied to my AP group. At this point, I can see that my SSID has been successfully created with the desired configuration. Moving on, the next steps involve configuring the Cisco ISE server. To do this, I navigate to the Administration tab and then select Identities. From the Identities page, I can create a user within the Cisco ISE database. This user will be used for the demo and will have access to the wireless network I just configured. I already have a user set up for this demonstration, so I'll simply edit the password to ensure everything is in order. Now I validate the changes, and that's it. With the default configuration, no further adjustments are required. We are ready to proceed with testing. On my PC client, I will connect to the SSID that I have created in OmniVista. I will use the credentials that I previously set up in Cisco ISE for authentication. And voila, I am now successfully connected to the network. To check the details, I will open Cisco ISE and examine the log. It seems like there is something noteworthy there. I can see the record of my activity, including the username connected, the MAC address of the endpoint, its IP address, and various other details. One of the advantages of using OmniVista to proxy the request to Cisco ISE is that we have access to these records in OmniVista as well. If I refresh the logs, a new entry corresponding to my recent activity should appear. Here I can observe the protocol that was used, the external radius server, the endpoint's IP address, the SSID, and more. That concludes our demonstration on .1x authentication. In this section, I will configure an external captive portal using Cisco ISE. For this demonstration, I will be using two access role profiles for pre- and post-authentication. ARP1 will correspond to a role with restricted access, while ARP2 will provide access to the network and internet. In this demonstration, I have a PC client that will connect to a guest SSID. Similar to the previous example, UPAM is used as the authentication server, and it will proxy the request to a Cisco ISE server. In response, based on the call station ID attribute, Cisco ISE will check if the MAC address of the endpoint is present in its guest database. If not, it will respond with a radius access accept packet with a specific filter ID of ARP1 and a redirection URL. Once the client is connected through the captive portal, Cisco ISE will send a radius COA, change of authorization, message, which will be proxied back to the access point. The COA will dynamically modify the device access, granting it ARP2 privileges. By following this configuration, we can effectively set up an external captive portal using Cisco ISE on the Alcatel-Lucent Enterprise OmniAccess Stellar devices and OmniSwitch. The third thing I will do is to create my two ARPs. For that, I will navigate to the Unified Access and select the Templates menu. On the left side, I will go to the Access Role Profile tab. By clicking on the plus symbol on the top right, I can create a new access role profile. Here, I will name my first IRP with restricted access as IRP1. Then I scroll down to the end of the page and apply the changes. I follow the same steps to create an IRP2. Once done, I will verify that I have both ARPs and apply them to the device. The next step is to configure the SSID. I will go to the Wireless LAN menu and select SSID. Clicking on the plus symbol allows me to add a new SSID. I will enter the name for my SSID and choose the guest open options. Even though I want to use a captive portal, it's mandatory to leave this option disabled. Moving to the next step, I will enable MAC authentication. I will keep UPAM as a radius server and go to the advanced options. Here, I will select an external server as the source and choose Cisco ISE. Once validated, I will configure a default access role profile at the bottom of the page. In case of a timeout or unavailability of the server, this profile will be applied to the endpoint, so it's important to choose a restricted profile here. I validate and apply to my IP group. Now I can see that my SSID has been successfully created. The next step is on the Cisco ISE server. I will create two authorization profiles for our two roles. To do this, I will navigate to the Policies, then Policy Elements, and select the Results tab. Here, I will search for authorization profile. While there are several pre-configured profiles, let's create a new one. This first authorization profile will serve for pre-authentication. I will choose a name, so let's say for example Stellar Web Redirect. Then I choose the device type. Now I want to scroll down to the web redirection option and check the box. In the value here, I will choose my guest portal. And then scroll down at the bottom. In the advanced attributes, I will look for the filter ID attributes. The value here will be set as ARP1, which should match the same name we previously configured in OmniVista. This filter ID will be mapped to the ARP1. Finally, I validate the settings. Next, I will create a similar profile for ARP2, but without the web redirect. I name it, select the device type, and define the filter ID as ARP2. Once validated, I have my two authorization profiles. We are almost good to go. Now I need to configure the policies for the guest access flow. So in the policy menu, I will look for policy set. Here, let's create a new policy set, and let's name it guest. Let's provide a brief description of it. Now let's open the condition editor and create a new condition stating call station ID ends with, followed by the SSID that I will copy from OmniVista to avoid any error. Like this. Now I can save the condition. Let's go to the advanced options. Here, in the Authentication Policy tab, it's important to expand the Action submenu on the right and select Continue instead of Drop. This ensures that when using MAC authentication with Cisco ISE, if a new device connects, Cisco ISE won't know the MAC address and will drop the packet. We want to reach the authorization policy instead, so it's important to set these settings. Speaking of the authorization policy, I will create multiple rules here. First, I will add a rule that says if the MAC address of the endpoint is not in the guest endpoint group, I will use the Stellar Web Redirect authorization profile. Then I will create a new rule above this one. This rule will use the guest flow, and I will select the authorization profile permit access ARP2. This means that if a user authenticates through the captive portal, they will be granted access with the ARP2 profile. Finally, I can add a third rule for the Remember Me function. Cisco ISE can remember the MAC address of a guest endpoint. In this case, I will add a rule that says, if the MAC address is already present in the guest endpoint group, then permit access with ARP2. This avoids requiring the users to re-authenticate each time. Now that all the rules are set, I can save and proceed to the test. On my PC client, I will connect to the guest SSID. The redirection page appears, that's cool. Before going any further, I can check my connected client on the access point. Using a specific command, I can see the current assigned ARP, which is in this case the ARP1, which corresponds to the restricted profile. In the Cisco ISE logs, I can observe the connection information and the current assigned role. And now let's log in with my guest account. After validation, it seems like I'm successfully connected, so that's cool. Let's verify the role on the access point. As you can see, it's now assigned as ARP2, indicating that the access role profile has changed. If I try to access a web page like YouTube, for example, let's see what's happened. It looks like we have internet access as expected. In the Cisco ISE, I can check the logs as well, which display the information about the current user and the device. Again, the advantage of proxying with OmniVista is having access to the records in OmniVista as well. I can see a new entry with the details of the connection.
All right, that's it for today's demonstration. I hope you find this video informative and convincing. Let's dive into some key takeaways now. Throughout this video, we've explored how easy it is to set up and configure .1x authentication, a fundamental protocol for ensuring the integrity and security of your network, using Cisco ISE and its database. Additionally, we've delved into a crucial aspect of your networks, the capability to use Cisco ISE external guest authentication portal with Alcatel-Lucent Enterprise OmniAccess tailors, ensuring that your networks remain secure while providing seamless access to your guests. We've covered essential configuration and best practices to create a network that fits your needs, all while ensuring traceability through detailed records and logs from both OmniVista and Cisco ISE. If you have any questions or would like to learn more about this topic, please feel free to reach out to us by joining our Spacewalker community at www.spacewalkers.com. Thank you for watching, and I'll see you next time.